This lesson we're going to be looking at gradient. Gradient, as we mentioned before, is a measure of actually how steep one of our linear lines are. So whether it's going up by a certain amount or down by a certain amount is what we call the measure of the gradient. Now you can see here from the writing that it's when we look at our general equation y equals mx plus c, the gradient is this value here that sits in front of the x. Okay, so it's the one that actually, the number that sits in front of the x when we have our equation written in this standard form. So m being gradient, and it's also called the rise over the run. You can see that's written as a bit of a fraction. It might be, for example, a 3 over 1. So we would say that the rise is actually 3, and the run of 1 would be the measure of the actual gradient. Gradient, before we even give it a number, can be looked at in a number of ways. We can call a gradient to be positive or negative. It can be 0 or undefined. And what I mean by that is if you look at these two lines here, the first line we'll look at is the one that looks to be going uphill. And what I'll say with that one is, if I write next to it here, that this graph has a positive gradient. Before I actually measure what it is, I can look at it and say, yep, that's a positive gradient going uphill. The one going the other way looks like it's coming downhill. Well, it is what we would say to have a negative gradient, simply from looking at it. It's not allowing me to go and work out what it is. It's allowing me just to say that that's what I can see it's doing. If we look at the positive gradient, what we might try and do now is actually measure it. Now, if you can remember back to the times when we were doing our distance between 2 points, the midpoint of 2 points, etc., etc., what I'm going to look at is on the positive gradient, I can see where it's crossing the x-axis, and I'll put a circle around it down there, and where it's crossing the y-axis. Two very distinct points on my line that I can recognize. If I was to use that point, the first and the second point, and actually make my little right angle triangle out of it, you'll be able to see that I can break it up into a rise and a run. Now the rise, up the y-axis here, so you can see my rise is going up there. How far that rise is, what we need to do is count, and if we can see, the lines are a little bit hard to see now, but if we look and try to count them up as we move our way along, you'll go 1, 2, 3, 4. So we're actually rising a value of 4. Okay, the run goes from little x-axis down there where it's crossing, and if we run across 1, 2, 3, 4, 5 spots, so that run is 5. Therefore, the gradient, which we know is positive and being a rise over a run, could actually be valued now, actually given a value of rising 4 and running 5. So it's positive 4 over 5 for that gradient, simply from making my little right angle triangle and recognizing how far I've come up and how far I've come across. The negative one can be done in a very similar way. What I would need to do is actually recognize 2 spots where the line's crossing. So if I choose a different color, I can see again this time where it's crossing on the y-axis, and this one it's crossing over here on the x-axis. I can see it's going downhill, so I know it's going to be a negative gradient. So if I make my little right angle triangle with it this time, and you can see in the green one there, what I've got is a rising part, or in this case actually a falling part. Starting at that circle here, I'm falling down 2 spots. So I'm coming down 2, or negative 2. And going across ways, I've got 1, 2, 3, 4. I've got a positive 4 going across. So my gradient becomes, again, rise over run, but in this case it's a rise of minus 2 over 4. So my gradient is negative 2 on 4. Like all fractions though, this one can actually be simplified to be minus 1 over 2. So it's got a negative gradient where you come down 1 and across 2, and you could end up back on the line. Similar to the positive one above, which was 4 over 5, which means from any point on my graph, I can go across 5 and up 4, or up 4 and across 5, and I will end up back on my same line. If we look at this little example here, and we had to try and calculate the gradient, okay, so we know, again, gradient is rise over run. So given a graph that's been drawn for us, let's actually put in our little right angle triangle. So there's a point down here, there's a point down up there that I can actually see definitely. I know by looking at it first of all that it's going to be positive because it goes up. So there's my simple answer. As long as my answer that I get in the end is a positive fraction, I know I'm on the right track. What we need to do is our little right angle triangle again, along this way, up this way. Look at our heights, this run across here, 1, 2, 3, 4 spots again. Our rise, 1, 2, 3, 4, 5 spots. It's a rising 5, running 4, gradient of 5 on 4. Like I was mentioning about simplifying fractions, don't simplify that 5 on 4 to be 1 1/4. We want to leave it as an improper fraction. Another one here this time, again, we can see it's negative just by looking at it. So my fraction I must ensure my fraction is going to be a negative one in the end. I can see a point, there's another point, make my little right angle triangle. Okay, what have I come down? I've come down 1, 2, 3, 4 spots. I've run 2 spots. So I've fallen 4, make it negative 4, run 2, minus 4 over 2 gives me negative 2 over 1. Or really, I just need to write negative 2 as my actual gradient. Okay, so this one has a gradient of minus 2. The one before had a gradient of positive 5 on 4. Here, a little bit different. This time I look at my graph, I can't really tell exactly where it's crossing. So if you notice on the two axes here, it's not exact. It's not quite sitting on that 2, so I really can't assume. What information I have been given, and I should just pretend it's a lot neater than what it actually is I can see that this point here is there, and this point like so, if it was a lot neater. So if I was to actually look at these points, and I could tell that this number was 1, 2, 3, 4, 5, the number 6 on the x-axis, this is the number minus 3 on the y-axis. Up here, I've got minus 3 on that x-axis, and I've got positive 3 on that x-axis. So I can see that point A would be referenced as negative 3 and positive 3, whereas point B would be represented as 6 and negative 3. Again, I can make my little triangle. So I can simply get my colour that I want, which I'll do it this time in green again, and from the point that I've got down to another point, so I can go down like so, come all the way across, and I end up with one bigger right angle triangle. But again, the same principle. Look at what I've come down there. I've come down a distance of from a height of 3 down to a height of minus 3. I've fallen 6 spots. And my run this time across the other way happens to have been all the way through there from a length of negative 3 on the x-axis up to positive 6 gives me a total distance of 9. So therefore my gradient being rise over run becomes a rise of minus 6 over a run of positive 9, which simplifies, 3 goes into them both, negative 2 over 3. Again, all I did was make right angle triangles out of my 2 points. Sometimes though, you're given information like this where you don't have a graph. So you're actually just being told that the line goes through the following 2 points. Well, there is a formula we can use. And the formula that we use is the following. M equals y2 minus y1 over x2 minus x1. And it's important to note that the 2's and the 1's are subscripts. So they're actually like little values, not squares and these sorts of things. What it's referring to is the following. I've got 2 points. Here's point 1, here's point 2. Okay, remember points are referenced with x and y. So there's x and y for both of them. But what I'm really saying is this is the x1, this is my y1, because it's from my point 1. So these ones over on this side, for example, obviously we're referring to point 2, so it's going to be called our x2 values and our y2 values. And we simply go and do a substitution into this formula. And you'll see the formula says the following. Take my y2 value, which is here, and substitute it into there. So my y2 value happens to be there, the number 20, and I substitute that in, 20. The rule says to subtract, so I know I've got to do subtraction. My y1 value, which is up here now, which is negative 5, over my x2 value. So notice again, it says down here, x2, and then it will say minus. So I know I've got to put in my x2 value, which happens to be the number 2, and I'm going to minus my x1 value, which is negative 3. Simplifying these, I get 20, subtract negative 5 gives me 25, because it becomes a plus, and 2 subtract negative 3 also becomes a plus, and it becomes the number 5. It says 25 divided by 5, well, the answer is just 5. So the gradient that joins of the line that joins those 2 points is positive. We can see it's a positive number, and it's also given a value of 5 in terms of its steepness. Here's one more little example. So the key is, as soon as you see that you've been given 2 points, think to yourself, I'm going to have to use this formula y2 minus y1 over x2 minus x1. So I need to nominate that to be 0.1, this to be 0.2. There's x1, there's y1, there's x2, there's y2. Let's go sub them in. y2 is negative 10. Subtract y1, which is 4. x2 is the number 1. Subtract negative 2 becomes minus 10 minus another 4 gives me minus 14. Positive 1 subtract negative 2 means I'm going to add, and I get an answer of 3. I cannot simplify negative 14 on 3, so that ends up being the answer to my gradient. That's all for the lesson on gradient.